Okay, good evening. Welcome to
MinuteMath number 40.
MinuteMath number 40. Now we were actually having a little trouble drawing MinuteMath from today on our whiteboard, so this isn't really MinuteMath, but we saw this really cool by heart video about candy corn triangles made of candy corn triangles, right?
Yeah.
So I thought what we would do is do Pascal's triangle with only ones and zeros. Do you remember how you make Pascal's triangle?
Yeah.
What do you do?
It's this. The new number is the sum of the two numbers above it.
Right, and the only rule here is going to be that 1 plus 1 equals 0. Okay?
Yeah.
Alright, that's our only rule. So on the outside we always have 1s, and what's the middle one here?
It's a 0.
What's the outside?
1.
Okay, so I always start with a 1. What's this middle one?
1.
1. And?
1.
And?
1.
Okay, now we start with a 1 and we get?
0.
0, because 1 plus 1 is 0.
0. 0. 1.
Start with a 1, what do we get?
1. 0. 0. 1. 1.
Start with a 1, what do I get?
0. 1. 0. 1. 0. 1. Hey, is the pattern of 1, 0, 1? 1. 1. 1. 1.
Stop saying 1.
1.
Stop saying 1.
1.
Stop saying 1.
1.
1. Notice anything interesting?
Well, only the second, the fourth, and the 8th row were all 1s.
Huh. You sure? Is there another row that's all 1s?
This is the first row.
So we have 1, 2, 4, and 8 are all 1s. Do you see a pattern there?
There's a pattern.
1, 2, 4, 8. So what do you think the next row of all 1s is going to be?
16.
Okay, notice anything else?
Well, the third and the fifth will have 1s on the outside, but the middles are all 0s.
Okay, that's interesting. I don't know when that'll happen again. Oh, wait a minute. 1, 0, 0, 0, 0, 0, 0, 0, 1. So, after you have a row that's all 1s, with the exception of the first one, after you have a row that's all 1s, you get a row that has only 1s on the outside and then 0s. So that's interesting. But what about this? Look at this little triangle here. Do you see any other triangles that go 1, 1, 1, 1, 0, 1, 1, 1, 1, 1? There's one there. Oops, sorry, one too far down. Any other ones? There. That's pretty interesting.
Kind of makes a Sierpinski's triangle.
Hey, interesting. And this next one's going to go 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. So
the ones that are creeping forward.
Yeah, they're creeping forward and it's going to go down. It's going to make some pretty neat patterns. It's actually really cool. Makes some very cool patterns. Pretty neat, right?
Yeah. And
you found some of the patterns. The 1, 2, 4, 8 row, and then 16 would be the next row that has all 1s, then 32.
Then 64, then 128, then 256. Let's
count the number of 1s in each row. So we get 1, 2, 2, 4, 2, 4, 4, 8, 2, 4. You notice anything about those numbers?
They're all even, with the exception.
Okay, with the exception of 1, I get 2, 2, 4, 2, 4, 4, 8, 2, 4. They're more than just even.
The powers of 2.
It seems like the number of 1s in every row is a power of 2. That's pretty interesting.
Yeah.
Yeah. And then make little triangles. So that's a neat thing to play with. I mean, if you had a piece of paper, you could make it go a lot farther.
And you wrote really small.
And you wrote really small. Or maybe we could do it on a computer and make it go brrr, but you're right, you get a little Sierpinski's triangle pattern. High five. Good job.